Today, we're diving deep into some pretty fascinating and you might even say invisible science. It's the kind of stuff that keeps the entire multi-billion-dollar oil industry from literally grinding to a halt. And believe it or not, it all comes down to a substance you would probably never, ever guess. So, let me ask you this. You're on a massive oil rig, surrounded by cutting-edge tech, all designed to do one thing: get oil out of the ground. What do you think is the single most important fluid in that whole operation? You'd think it's the oil, right? I mean, that's the whole point. Well, you're in for a surprise. Yep, it's the mud. But we're not talking about the stuff you make mud pies with. Oh no. This is a highly engineered, scientifically perfected fluid that is, without a doubt, the secret hero that makes modern drilling even possible. All right, so let's get to know this unsung hero a little better. What in the world is drilling mud, and why is it so ridiculously important? Think of it like this. Drilling mud is basically the circulatory system, the lifeblood of the entire well. At its most basic, it's a mix of a special clay called bentonite and water. But when you mix them together, the clay kind of wakes up. It hydrates and turns plain old water into this precisely controlled sludge that keeps the whole show running. And this stuff is a serious multitasker. It has to be viscous enough, thick enough, to carry all the bits of rock that the drill chews up back to the surface. It's also got to be thin enough to be pumped down in the first place. At the same time, it's cooling and lubricating the drill bit, which is getting incredibly hot. And it's putting just enough pressure on the walls of the well to keep the whole thing from collapsing in on itself. It's a really delicate balancing act. But what happens when that perfect balance gets thrown completely out of whack? Well, this is where our story takes a dark turn, and we have to investigate the scene of a chemical crime: contamination. So what counts as contamination? It's actually pretty simple. Any foreign stuff that gets into the mud system and messes with that delicate chemical balance is a contaminant. And that can cause all sorts of unwanted changes, affecting everything from how thick it is to how well it does its job. And here they are, the usual suspects. You've got things like salts or salt water that can seep in from the rock formations you're drilling through. You've got gypsum, even cement from other parts of the operation. These are the culprits, the bad guys that can throw a wrench in the works and bring a multi-million-dollar drilling operation to a screeching halt. And here's what that damage actually looks like on a chemical level. A lot of these contaminants, especially ones with calcium in them, cause the tiny clay particles in the mud to start clumping together. It's a process called flocculation, and you can see the results right here. Key properties like viscosity and gel strength just plummet. And what does that mean? It means you're drilling slower, less efficiently, and way, way more dangerously. Okay, so you know your mud is sick, but you don't know what's causing it. How do you find the culprit? Well, it's time to put on our detective hats and start a full-blown chemical investigation. Out on the rig, this is the mud engineer's #1 forensic tool. It's a titration kit. Now, it might look a little complicated, but it's really all designed to answer two very simple questions. 1, what has gotten into my mud? And 2, exactly how much of it is there. So what exactly is titration? You know what? Think of it like a chemical interrogation. You take your mud sample, your suspect, and you add a known solution called a titrant, drop by painstaking drop. You're looking for a specific color change. When that color pops, the reaction is done, and boom, you can calculate the identity and the exact amount of that hidden contaminant. The whole process is super methodical. You get your sample ready, you add a special indicator chemical that's designed to change color at just the right moment, and then you carefully add that titrant. That final color change, that's your aha moment. That's the endpoint that tells you the chemical secret you've been looking for. And one of the very first clues an engineer is looking for is something called water hardness. It's just a way of measuring how many calcium ions are floating around. Now, looking at this table, you can see that once you get above 300 milligrams per liter, you're officially in the very hard zone. And for drilling mud, that is a massive red flag for big-time trouble, like that flocculation we talked about. So the investigation is complete, the contaminant's been identified, now it's time to prescribe the antidote. And this isn't guesswork, folks. This is all about precise, targeted chemistry. Let's say salt water from a deep underground formation has seeped into your mud. The treatment can be pretty direct. You've got a couple of choices. You can either dilute the whole system with fresh water to bring that salt level down, or if it's really bad, you just lean into it and convert the whole system over to a special salt-based mud.
And just about every problem has its own specific chemical fix. For example, if you get cement contamination, you've suddenly got a flood of calcium ions messing everything up. The go-to care for that is soda ash. You add it in, it reacts with the calcium, and poof, it causes the calcium to precipitate, to basically drop right out of the solution as harmless chalk. Problem solved.
It's a similar story if you drill into a formation of anhydrite or gypsum, another big source of calcium. Again, you've got choices. You can treat it with soda ash, just like you would with cement, or you can actually convert your whole system to a specialized gypsum mud that's designed to handle it from the get-go. So, what's the big picture here? What's the main takeaway from all this chemistry? It's that in these massive, complex operations, precision is absolutely everything. It's all about using science to stay in control and keep things running smoothly. And really, it all boils down to this. The success or failure of a billion-dollar drilling operation can hinge on keeping the perfect chemical balance in a big vat of clay and water. That mud engineer is part detective, part doctor, using precise chemical analysis and targeted treatments to fix problems that are totally invisible to the naked eye. And that kind of leaves us with one final thought, doesn't it? Our world is just full of these incredibly complex chemical systems that we rely on every day, from the gasoline in our cars to the clean water coming out of our taps. It really makes you wonder, what other invisible science is out there hiding in plain sight, just quietly making everything work? Thanks for joining me on this one.